this into a second video just because the other one was getting too long. Sometimes I have trouble getting them to upload if they're too long. So question 4 and 5. For question 4, the first thing they're asking you to do is do the test for the homogeneity of variance. And so we're going to use what they call the F-max test for that. And all it is just taking the two variants. I think your formula is also on this page. Check. Yeah, you're given the formula, and so it is just the largest of the variances divided by the smallest of the variances. And variance means that we're just squaring the SD. So we're going to take 3.19 squared, and we're going to divide that by 2.41 squared. I get a value of 1.75 there, and if the F crit that you're given, let me just find that again. I think you're given an F crit of 3.6. 33. And so in that case, we can assume homogeneity of variance because it's not in the critical region. It's below the 3.633 value. So if we can assume that, then that was part A. Part B, then you can go therefore and so on. But for part B, it says based on your findings for part A, for the most appropriate test. So we can use a t-test now that we have homogeneity of variance. And we have two groups, 5 people in the first group, 10 people in the second group. We have an average for the first group and an average for the second group. And we have 2 different SDs. So again, we're going to calculate our pooled variance. And then we're going to use our t-test with the pooled variance. And we're going to compare that to the t-crit. Yeah, you would make your hypothesis statements. You'll do your test at 0.05 alpha again. You find your pooled variance. You find your t-value, and then you decide on whether there is a significant difference between these two groups. And so that's all there is to it for that one. I'm just going to go on to number 5 and show you how to set that one up. Alright, for this last question, for question also chi-square, but this is a chi-square test of independence rather than goodness of fit. And so we do this one a little differently. First of all, what we need is totals, and so our row totals are here, but we don't have our column totals. Our column totals are 300 and what's this one going to be, 73? And then the column total here is going to be 258. And so what we're going to do is we're going to get all of our expected values. These are all of our observed values that we're going to use, these ones in the chart. We need our expected values, and we have to calculate that for all 4 of these. And so how we do it is, let's start with involved in a fight for the low school involvement group. So I'll just put sub-low. And so there are 427 involved in a fight times 373 that are from the low school involvement, and the total here is 631. And so you're going to work that out and get 252.41. You could round that off because it's numbers of students, so it's discrete data. So you could round off to 252. And if we keep going, if we have involved in fight, but we have high school involvement this time, then what we're going to do again is take the 427 from the row total, but this time we're going to multiply by the 258 from that column total, from this column, and still divide by 631. That's going to give us a value of 174.59. And if we keep going, we've got the other 2 to do now, which is not involved in a fight. And then we'll we'll do low and high on that one. And so the low would be 204, because that's our row total, times 373, because that's our column total, divided by 631. That gives us 120.59, and again we can round these off to the nearest whole number. And then not involved in a fight, but high school involvement is going to be 204 times 258, because that's this total here, over 631. And so we end up with, 83.41 or 83 there. And so you're going to do a chi-square calculation, the same as we did in the first question, where we do observed versus expected squared over expected. But we had to work out the expected values this time. And so if we're doing the chi-square, calculation, we want observed minus expected squared over expected. And so we would have, for instance, 316 minus 252 all over 252, and this part is squared, and then we would have 111 minus 175 all squared over 175, and so on. So we're just going to carry on and put in those numbers. 121, I guess, here, all squared over 121, and then the last one is going to be 147 minus 83 squared over 83. And that's going to give you your chi-square value, and then you're going to compare that to the for degrees of freedom 1, because we only have two categories, and your alpha level